In class today, we're talking about finding the sum, or rather the area under a curve, using midpoints and trapezoids. Okay, rather than using the left hand and right hand like we were doing yesterday, we're going to use midpoints and trapezoids. So with a midpoint, you have to decide how many intervals or subdivisions you are dividing your rectangles into. Okay, so let's say we're going to find the interval, the area from here to here, and we're going to divide it into 3 sections. So we have 3 subintervals. Now these are even subintervals. Okay, they don't have to be even subintervals, but usually when we do these, there are even subintervals. Okay, so what we're going to do is we're going to find the midpoint. So we're going to actually use the y value associated with here, right? The middle of our subdivision. And we're going to use the y value from here, and we're going to use the y value from there, right? We're not going to use the left or the right endpoints of our rectangle. We're going to use the midpoints. So when we make our rectangle, we find out what is the y value here. Okay, and then we make your rectangle. So as you see, we have part of it that's above and part of it that's below, okay, which is a better approximation of the actual area of that rectangle. Okay, so here we're going to use this midpoint, so we come up to its y value of the midpoint, and you make your rectangle from there. Rather than the left or the right endpoint, you make your rectangle from the midpoint, okay, which gives a better approximation. Okay, and then our third interval, we come up to where it hits the y-axis, and you make your rectangle from there. Okay, so notice in this method, right, we have a little bit above over here, but then we have below on this side. Okay, and hopefully these will average itself out and give you a decent approximation. Right, on this triangle, we have a little bit that we're missing from there, but we have a little bit that we're adding from here. Okay, and maybe we have, right, a couple of overestimations there. So the midpoint is a better estimation than either the left endpoint or the right endpoint, the left hand or the right hand method. Okay, but we're remembering you have to use the y value from your midpoints rather than from the x coordinates of your subdivisions. Okay, that's the key to doing the midpoint method, is you have to use the y values from the midpoints rather than from your rectangle edges. Okay, now over here with the trapezoid method, okay, remember the area of a trapezoid, since this is area under the curve, that's 1/2 of the sum of your bases for your trapezoid times the height. Now if you remember what a trapezoid looks like, right, trapezoids have bases that are parallel. So for our application, we're not going to have a horizontal trapezoid, we're going to have vertical trapezoids. Okay, where these are your parallel parts, right? These are the y values for your given x values. Right, where this is going to be the height of your trapezoid, the distance in between your bases. So the height of your trapezoid is going to come from your delta x. Right? It's going to come from the change in x. So how wide are each of your trapezoids? Okay, so we're not going to have a horizontally oriented trapezoid like we would normally draw ourselves in geometry. We're going to have a vertically oriented trapezoid where your bases are the y values and the height is the x value. Okay, so when we do our calculations, those are the values that we're going to be putting in. Okay, so let's do this. Let's draw this picture and see if it looks any nicer. So we're going to have, let's use the same 3 subintervals. So we're dividing into 3 equal sections, and they don't have to be equal, right? You can make them wider if you want to. So the trapezoid, right, we go up vertically until these both hit the y-axis, and then you draw in your connector. Right, so here is trapezoid 1. Okay, another trapezoid, you have another base Here is trapezoid 2. And then here is our third trapezoid. Maybe something like that. So it looks like there's a lot less of an overlap, right? A lot less gap here between your trapezoid and your actual graph. Okay, maybe there's an over approximation in here, right? And of course, the smaller the intervals that we take, the better the approximation is going to be. Okay, but we're just going to take small, or rather big intervals just so we can do the algebra or the math pretty easy. Okay, so let's look at a couple of examples using some tables and see if we can make sense of these methods. So here I have a table, right? I have a x value at -3, -1, +1, 3, 5, 7, and 9. So each of these has a corresponding y value for what we're going to do. Okay, now number 1 says find the integral from -3 to 9. So that's the whole entire shebang here, right? The whole entire interval with 3 subintervals using the midpoint method. Okay? So we're going to figure out how wide do each of our subintervals need to be. Okay, so from -3 to 9 is 12 units, and we want to divide that into 3 equal subunits. Okay, so how wide does each subdivision need to be? 4 units wide. Okay, so let's look at, so we're just going to make a quick little horizontal graph here, a little line graph. We're going to start at -3. What is the next x value 4 units away from -3? +1, and then 4 units away from that is +5, and 4 units away from that is +9. Okay, so these are the x values that will divide our interval into 3 equal subdivisions. Okay, so we need to use the midpoint. So what is the x value that's the midpoint of -3 and 1? What's the middle of -3 and +1? -1. So look at our table. What's the y value for -1? 2. So we're going to go up 2 units, and we're going to make our rectangle. That is the midpoint Riemann sum, right? The first rectangle of our area under the curve. Okay? And then we move over. What's the midpoint of 1 and 5?
3.
3 is the midpoint of 1 and 5. And what's the y value for 3?
-7.
-7. So I'm going to go down -7 units, and that's going to become the height of my rectangle for the area between 1 and 5. -7 is that height, and this is 2. And then the midpoint of 5 and 9 is 7. And according to my table, the y value is 6. So I'm going to go up to 6 units, and that's going to be the area that represents my third subdivision. Okay, so we're finding the x values that are the midpoints, right? The midpoint is an x coordinate, and we are using the y coordinate of that midpoint to represent the height of your rectangle. Okay, so now if we're going to actually calculate this, right, so formally speaking, we're going to find the integral from -3 to 9 of our function h of x dx is approximately the area of each of these rectangles added together. So what's the area of my first leftmost rectangle? Okay, it has a height of 2, and what's the width? The width is 4, so 2 times 4 is 8, plus the area of my second rectangle with a width of 4 and a height of -7, so that's -28, plus my last area with a width of 4 and a height of 6. 4 times 6 is 24. So 8 minus 20, 8 is -20. -20 plus 24 is 4. So the integral from -3 to 9 of this function is going to be 4 if we use the midpoint Riemann sum method with 3 sub-intervals. Okay, so we're finding the areas of rectangles, but rather than using the x coordinates or the y coordinates of your endpoints, like we did with the left or the right, we're using the y coordinate of the midpoint. Okay, so let's see how that's different if we use our trapezoid method over here. Okay, so let me erase some stuff. So number 2, we're just asked from -3 to 3. Okay, we're just asked for this interval, which is 6 units long. And if we're going to use 3 sub-intervals, how wide is each of our units going to be? 6 divided by 3 is 2. Okay, so when we make our trapezoids, we're going to be using units that are 2 apart. So we're going to use -3 and -1 and +1 and +3. Okay, so we're using 3 sub-intervals. As you can see, there are 3 spaces, right, between -3 and -1, -1 and 1, and 1 to 3. And each of these are 2 units wide. Okay, they don't have to be even, but in this case, they are. So what we want to do is draw our trapezoids. So we're going to use the y value from -3 and the y value from -1. So first we're going to go up to +5. Okay, that's the y value for -3. And we're going to go up to +2. That's the y value for -1. Okay, and then this becomes your trapezoid. Okay, and in a second we're going to find the area of that trapezoid. Okay, so now let's move over. What about +1? For +1, the y value is -3. So that's down 3 units. Okay, so we're going to have to make our parallelogram look, our trapezoid look like this. Okay, since we don't have a horizontal side like we did before, you have 2 slanted sides, but that's okay because our trapezoid still has parallel y lines, right? That's what it makes to make a trapezoid, is 1 set of parallel lines. And then our third one, we have a y value of -7, right? At +3, the y value is -7. So we're going to go down here to -7. And now we have a trapezoid that looks like this. Okay, so we're going to find the area of each of these trapezoids and then add them together to get the area under the curve. Okay, so let's look at the red trapezoid first. So the area of a trapezoid is 1/2 the sum of the bases. Now remember, your bases in this case are your y values because these are the parallel sides. So we have a y value of 5 and a y value of 2. Okay, your parallel sides are the bases. So your bases are your y values. Times the height of your trapezoid, which in this case, this becomes your height, the distance between your bases. And your height is the x value. So in this case, we have an x value of 2. Okay, so that's important to remember also, is that your height is your x value, the x differences between your 2 y values. Okay, so then let's move over to the blue one. 1/2 of the bases, so the left base is +2 again, and the right base was -3. And it still has a height of +2, right? That's still the x value that separates your 2 bases. And our pink triangle here, or rather trapezoid, has an y value of -3, right? That's the left one, -3, and -7 as the right base. And we're going to multiply that by 2 also. So we're doing each of these areas individually, and then we're going to come back and add them up right now. So 1/2 of 7 times 2 is 7. 1/2 of 2 minus 3 times 2 is -1. And 1/2 of -3 plus -7 is -10. Okay, it's really nice if we have a height of 2, because that directly cancels out that 1/2, and then you just have to add your y's together. So if we add all these three things up, we get the integral from -3 to 3 is 7 minus 1, which is 6. 6 minus 10 is -4. Okay, and it's approximately, so we'll use the approximate symbol. Okay, so with trapezoids, your y values are your bases, and your x value is the height. Okay, so let's see if we can put this last one together with number 3 using 6 sub-intervals and the trapezoidal sum. Okay, so again, all these are going to be 2 units apart, and we're going to use all the y values. So this is what all of our trapezoids look like. So now we're going to find the area of each of them. So I'm going to call these little a and b and c and d and e and f. And we're going to compute the area for each of these separate trapezoids and then add them all together. So remember, the area is 1/2 of the left y value plus the right y value times the height, which is the x value. So I'm going to do this for all 6 of these and then add them all up. So this is all the areas of each of my trapezoids, because all the 1/2s and the 2's cancel, so it's basically just the sum of your 2 y values for each of these trapezoids. Okay, so then when I actually do my integral, right, if I take the integral from -3 to 9 of my function h of x dx, this is approximated by simply adding up all of my areas of my trapezoids. That's a -10 plus -9 plus 4 plus 17. Okay, when I add all these things up, I get 8. Okay, so when we're using trapezoids, you have to be cognizant or aware of your different x values. The x value is the height of your trapezoid, and the y values are your bases. Okay, so sometimes it's nice to choose a height like 2 that cancels out nicely with your area formula so that it improves your calculations a little bit. But remember, the more sub-intervals you make, the better the approximation will be. Okay, that is all.